Jonathan Pevsner. I'm an associate professor in the Department of Neurology at the Kennedy Krieger Institute. I'm also a faculty member at Johns Hopkins in the School of Medicine. My laboratory studies the chromosomal basis of childhood brain disorders, including autism. Here at the Kennedy Krieger Institute, we have about 18,000 patients come each year, and many of them have rare disorders involving the development of the nervous system. We study the genetic or chromosomal basis of these disorders. One of the barriers to adopting next-generation sequencing was the sequencing machine itself, which was expensive. And now we use a MiSeq, which is relatively inexpensive. Illumina has been a great partner to work with on this kind of project because they offer the technology to do the sequencing, but also we've had a chance to develop a workflow from beginning to end, from designing the contents of a custom autism panel to actually implementing the panel and seeing results come out, and we've worked together on the data analysis end of it as well. The whole next-generation sequencing workflow is so simple now. One of the really hard parts at the front end is deciding how to do a custom sequencing project. And here, with a panel focused on autism, we know already what genes we'll be studying up front, and we can see what to expect when we get our data back. Actually doing the experiment has become easier and easier because there's a well-understood workflow. Data quality is everything when we're doing next-generation sequencing. We have information from each sequencing read about the quality. We have FASTQ files with quality scores associated with each base. And from this in the workflow, we can choose appropriate thresholds, such as Q30, where we can tolerate 1 error per 1,000 base pairs. We help to design the TrueSight Autism targeted sequencing panel by selecting genes that are already implicated in autism. We picked ones that are involved in single gene disorders such as MECP2, known to be associated with an autism-like phenotype. We picked others which have been identified in whole exome sequencing projects which identify recurrent mutations occurring in multiple individuals, which we believe will be excellent candidates for this panel.